Welcome to YouTube channel. In this lecture, I will discuss about how to add and subtract integers. First of all, you will need to know what are integers, how to represent integers on the number line, adding and subtracting whole numbers. It is better if you know about rounding numbers. In this video, you will learn adding and subtracting integers on the number line, subtracting a positive integer, subtracting a negative integer, as well as estimation of adding and subtracting integers. Integers may be 0, positive or negative. Integers can be marked on a straight line called the number line. In other words, the number line can visually represent integers on the straight line. Here is 0. The values of integers are greater on the right side of the number line. Positive integers are on the right side of 0. A positive integer is a whole number greater than 0. In contrast, a negative integers are on the right side of 0. A negative integer is an integer with a value less than 0. We can add and subtract integers on the number line. It is very simple. You need to know how to count numbers. When we add a positive integer, the value increases. So, to add a positive integer, we can count towards the right side of the number line. In contrast, subtraction decreases the value. So, when we subtract, we can count toward the left side. Let's try these examples. When we add negative 4 and 6, we start from negative 4 on the number line. Since we are adding, we count towards the right side. We'll count 6 steps toward the right. Now we reach 2. So the answer for negative 4 plus 6 is 2. Let's try another one. We are adding 8 and negative 3. We start counting from 8. When we add numbers, we will count towards the right side. But here, we are adding a negative integer, and we need to follow another rule. We need to count towards the opposite direction for the negative integer. So, instead of counting towards the right, we have to count towards the left. It is the same as subtraction. So, 8 plus negative 3 is the same as 8 subtract 3. Count for 3 steps and we are now at 5. The answer for 8 plus negative 3 is 5. For negative 3 plus 5, we start from negative 3. To add negative 5, instead of counting toward the right, we have to count toward the left. Negative 3 plus negative 5 is the same as negative 3 minus 5. Then count 5 steps and it is negative 8. That's the answer. We can also subtract integers on the number line. Here is 2 minus 6. Start from 2, count towards the left for the subtraction. When we count 6 steps, we'll get the answer. 2 minus 6 is negative 4. Negative 4 minus negative 3. Start from negative 4 and direct towards the left for subtraction. Here we are dealing with a negative integer, that's negative 3. So we need to count toward the opposite direction, to the right. It is the same as adding a positive integer. So negative 4 minus negative 3 is the same as negative 4 plus 3. When we move 3 steps to the right, we reach negative 1. That's the answer for negative 4 minus negative 3. 2 minus negative 4. We start counting from 2. For subtraction, the right towards the left. However, we are subtracting a negative integer and we need to change the direction. It is like 2 plus 4. Count 4 and now we reach 6. So the answer for 2 minus negative 4 is 6. When we add integers, check the sign of each integer. Is it positive or negative? If the signs of the integers are same, we can simply add the absolute values of the integers. The answer is the same sign as the integers. If the signs are different, like adding a positive integer and a negative integer, subtract the smaller integer from the larger integer. Then give the answer the same sign as the larger integer. For subtraction, there are also some shortcuts. Subtracting a positive integer is the same as adding a negative integer. When we subtract a negative integer, we can change the expression as adding a positive integer. We can use these rules to solve the problems. In this exercise, you need to add and subtract integers. Copy on your workbook, pause the video and work out the problems. Then check your answers. Now I will explain how to solve the problems. -3 plus 4 is like adding integers with different signs, -3 and +4. So we need to subtract the smaller integer from the larger integer. 4 subtract 3 is 1 and 4 is greater. So the answer is +1, or we can simply write 1. 3 plus -7. The integers have different signs, +3 and -7. 7 minus 3 is 4. 7 is greater and the sign must be the same as that of 7. -4 is the answer. -4 plus -4 is like adding integers with the same signs. 4 plus 4 is 8. Adding negative integers will give the negative answer, -8. 9 and -5 are integers with different signs. 9 subtract 5 is 4. 9 is larger, and the answer is +4. We can simply write 4. -1 minus 5. Subtracting a positive integer is the same as adding a negative integer. Both integers are negative and we add 1 and 5 and get 6. Since they are negative integers, the answer is -6. For 3 minus -5, subtracting a negative integer is the same as adding a positive integer. We can do 3 plus 5. The answer is 8. -3 minus 7 is like adding -3 and -7. They both are negative integers. When we add the absolute values, we will get 10. They are negative integers and the answer is -10. -4 minus -6 is the same as -4 plus 6. They have different signs. So we do subtraction. 6 minus 4 is 2. 6 is larger and the answer is 2. For 4 plus -6, we can follow the rules for adding integers with different signs. 6 minus 4 is 2 and 6 is larger. So the answer is -2. 4 minus -6 is the same as 4 plus 6. We can simply add 4 and 6 to get 10. -4 and -6 have different signs. So 6 subtract 4 and we get 2, which is the answer. -4 minus 6 is like adding two negative integers. Add two integers to get 10 and we need to put a negative sign for the answer because both integers are negative. In exercise 2, we need to find the missing number in the boxes. In each question, 6 plus a missing number give different answer. Can you find the missing numbers? Pause the video and solve the questions. First, I will explain how to solve the problems using the number line. We start counting from 6. In the first question, 6 and a number adds up to 10. To find the missing number, we need to count the numbers from 6 to 10. It is 4 steps and we are counting towards the right. So the answer is +4, or we can simply write 4. For second question, we count from 6 to 4. 4 is 2 steps to the left of 6. So the answer is -2. Here we count from 6 to -4. It is 10 steps towards the left side, which gives the answer -10. Here 0 is 6 steps away from 6 and we are counting to the left. So adding 6 and -6 will get 0. We can see that -6 is the additive inverse of 6. When you add a number with its additive inverse, the sum of the number becomes 0. In these problems, you may notice that we can get the missing number by another method. When we add additive inverse, -6 in this problem to the sum, we will get the missing numbers. Alternatively, we can also subtract 6 to get the same result. Here is another question. We need to convert mathematical expression from the question. Two integers add up to -4. There are two unknown integers and their sum is -4. One of the integers is 5. We can put 5 in one of the two boxes. We have to work out the other integer. The question can be solved by different methods. We can start counting from 5 towards -4. There are 9 steps between these two numbers and directed towards the left side. So the other number is -9. We can also add additive inverse of 5, which is -5 to -4. We can subtract 5 from -4. All three methods give the same result. In this exercise, the question states that -1 and 7 is a pair of integers that add to 6. Can you find the 4 pairs of integers that add up to 1? There are 4 pairs of integers and they add up to 1. We will assume the first integer and find the other integer. If an integer is 1, we can find the other integer by adding -1 with 1. 1 plus -1 is 0. If an integer is 2, we can add -2 with 1. 1 plus -2 is -1. 2 and -1 also add up to 1. If an integer is 3, we can add -3 with 1. 3 and -2 also add up to 1. We can use the same method to find other pairs of integers that add up to 1. Here, 4 and -3 also add up to 1. There are more than 4 pairs of integers that add up to 1. How can you see immediately that two integers add up to 1? If we carefully observe these pairs of integers, we can see that the difference between these pairs of integers is 1. Cycle and triangle are two integers. These shapes represent two different integers. Can you prove that cycle plus triangle and triangle plus cycle have the same value? If you can prove, do you know what does it mean? We will prove this question using the number line. We can use two arrows with different lengths to represent two different integers. For cycle plus triangle, we start from 0 and put a red arrow to represent cycle. At the end of red arrow, we continue putting green arrow to represent triangle. This is the number that represents cycle plus triangle. For triangle plus cycle, we can also use similar method but in different order. First, we put a green arrow. At the end of green arrow, we put red arrow. This represents triangle plus cycle, and the end of red arrow is the same as cycle plus triangle. Now we prove that cycle plus triangle equals triangle plus cycle. This is called commutative property of addition. When we add, changing the order of number does not make difference to the answer. We will get the same answer, and this property is true for adding any pair of integers. The next part of question is, do cycle minus triangle and triangle minus cycle have the same value? And give evidence to justify your answer. We can use the same method for subtraction. We start putting the red arrow on the number line. In this case, we are subtracting the triangle, so we change the direction of green arrow. This is the answer for cycle minus triangle. For triangle minus cycle, we put green arrow. Then we change the direction of red arrow. The end of the red arrow is different from the previous case. Now we can see that triangle minus cycle is not equal to cycle minus triangle. In subtraction, changing order of number gives different results. So we can conclude that subtraction is not commutative. We can use a pair of different integers to justify the answer. For example, 2 subtract 1 is 1. When we change the order, it is like 1 subtract 2, and the answer is negative 1. They are different, and we can clearly see that subtraction is not commutative. From this exercise, you need to learn that addition has a commutative property, but subtraction doesn't. In exercise 5, we will add 3 integers. Pause the video and solve the problems. Now you can check the answer. Let me explain how to work out these problems. There are 2 operations, both are addition. We can add one after another. Here, negative 3 plus 4 is 1. Then we can add 1 and negative 5. The answer is negative 4. All the problems can be solved by the same method. We can observe that all answers are negative 4. Why are we getting the same answers? In these questions, we are adding same integers in different orders. We are adding same integers in different order, and we can record the commutative property of addition. When we add numbers, changing order does not make the difference to the answer. This property is also true for adding any 3 integers. Exercise 6 shows the addition table. In the table, the first row contains 3 integers, negative 4, 6 and negative 2. The first column contains 2 integers, 3 and negative 5. Add an integer from the first row and an integer from the first column to get the answer. For example, 3 and 6 adds up to 9, which is already written in the corresponding cell. You can try adding numbers and check your answer. Pause the video and try it for yourself. 3 and negative 4 adds up to negative 1. 3 and negative 2 add up to 1. Negative 5 and negative 4 add up to negative 9. Negative 5 and 6 add up to 1. And finally, negative 5 and negative 2 add up to negative 7. In exercise 7, you can see the addition pyramids. Copy and complete the addition pyramids. We can add the 2 blocks to get the number above these 2 blocks. Here is an example. 3 plus negative 5 is negative 2. Negative 2 is already written in the block above 3 and negative 5. You can try adding numbers and then check your answers. You can pause the video when you are solving. Negative 5 and 1 add up to negative 4. Negative 2 and negative 4 add up to negative 6. We solve all the blocks in the first pyramid. We can use the same method to solve the blocks for the other pyramids. In this pyramid, we can think a little bit different. 2 and another integer add up to 3. We can get the answer by subtracting 2 from 3. So the answer is 1. This method can be used to fill all the other blocks. You got all the correct answers right. Now let's solve question number 8. Copy and complete the addition table. You can use the same method from the exercise 6. Adding an integer from the first row and an integer from the first column to get the answer in the corresponding cell. Now, add 4 integers inside the table. We can add integers in any order because addition is commutative. Finally, we add 10 and negative 4. So, the sum of all 4 integers is 6. Now, we add 4 integers on the sides and the top of the table. 4 plus negative 3 is 1. Negative 5 plus 7 is 2. And we add 1 plus 2. We get 3. What do you notice about these two integers, 6 and 3? We can see that the sum of the integers inside the table is 2 times the sum of integers on the side and the top of the table. How can we justify for the answer? Let's draw the similar table, and we put 4 different colored shapes to represent different integers. In each cell, we fill a shape to represent addition. Triangle and square, circle and square, triangle and rhombus, and circle and rhombus. When we add all the squares, we will have 2 copies of all shapes. Now we will add the integers on the side of the table. It is square and rhombus. When we add integers on the top of the table, we will have 1 copy of each shape. So we can conclude that the statement is true for addition table with 2 rows and 2 columns. Sometimes when we add or subtract, we estimate answers. For estimation, we need to round the numbers. You can record that rounding is replacing a number with an approximate value that has simpler representation. For example, look at these expressions. We will estimate the answers by appropriate rounding. By rounding numbers, we can calculate more quickly and easily. Negative 48 plus negative 73. Here we can estimate answer by rounding to nearest 10. 48 is rounded to 50 and 73 to 70. Negative 50 and negative 70 add up to negative 120. Thus the estimate for negative 48 plus negative 73. Now we round to the nearest hundred for 123 and 393. They are rounded to 100 and 400. 100 minus 400 is negative 300, which is the approximate answer. For the last question, we can round to the nearest whole number, 6.1526 and 4.8725. We can easily calculate 6 minus negative 5 or 6 plus 5. Then the estimate is 11. If you want to learn more about rounding, you can watch the specific lecture about rounding numbers. Now, let's estimate answers for the following expressions. For the first 4 questions, we'll round to the nearest whole number, and for the remaining 4 questions, we'll round to the appropriate numbers. Estimate and check your answers. You got all the correct answers, right? Now let's do exercise 10. Read the question, pause the video and try it for yourself. Now I will explain how to solve the problem. The question is a little bit tricky. 3 integers are equally spaced on the number line. Here's the number line and 3 integers are marked here. The spaces between these integers are equal. 2 of the integers are 3 and negative 7. What is the other integer? First, we need to place these integers on 2 of the 3 marks. Negative 7 is less than 3, so it lies on the left side of the number line. Another number is 3. Now we can calculate the space from negative 7 to 3. 3 minus negative 7 is 10. Since the spaces between the integers are equal, another integer is 10 spaces to the right of 3. We can add 3 and 10, so the other integer is 13. The last part of the question is that, is there more than one possible answer? Yes, there are, but how can we find the other possible answers? We can place -7 and 3 like this, leaving the leftmost mark. The space between -7 and 3 is 10, and we can find the other integer. In this case, we can think like the remaining integer plus 10 equals -7. The answer is -17. So, -17 is another possible answer. Can you think one more possible answer? Let's put -7 and 3 like this, leaving the middle mark. The space between -7 and 3 is 10. The remaining integer is in the middle of -7 and 3. Each space is half of 10, so the middle mark is 5 spaces away. Now we can find this integer by adding -7 and 5. The other possible answer is -2. In this question, there are more than one answer: 13, -17, or -2. How many answers did you get? This is the end of the lecture for adding and subtracting integers. At the end of the lesson, you should be able to add positive and negative integers as well as subtract positive and negative integers. Moreover, this video covered how to estimate when we add and subtract numbers. You should be able to record additive inverse and commutative property of addition. Thank you for watching this video. Don't forget to subscribe to our channel. Bye bye.